You're driving down the road, perhaps on a clear, sunny day, and you pass a scene that makes your stomach clench, a fatal car accident. A moment of solemn reflection, and then, perhaps, a subconscious thought might form, well, that's done. I heard there's a fatal accident every 16 minutes, so I guess I'm safe for a while. It's a comforting, albeit deeply flawed, piece of reasoning. The grim reality is that the next tragedy could unfold just seconds later, right in front of you, especially if you're rubbernecking at 70 miles per hour. This isn't just about traffic, though. This line of thinking, this solace we sometimes take from averages, extends to far grander, more cosmic scales. Many of us find comfort in expert pronouncements like asteroids similar to the one that killed off the dinosaurs 66 million years ago hit the Earth only once every 100 million years. It sounds reassuring, doesn't it? A neat, tidy number that pushes the problem far into the distant future. But just like our road accident analogy, such numbers are merely averages. And when we delve a little deeper, we begin to uncover the unpredictable truth hidden behind these seemingly solid statistics. The next truly devastating asteroid could rain down on us an hour from now, or in a month, or indeed in 150 million years. Let's take a closer, more thoughtful look at those averages, because they form the bedrock of our understanding, and often our complacency. According to the experts, the celestial body responsible for the dinosaur extinction, estimated to be around 10 kilometers or 30 miles in size, arrives, on average, once every 100 million years. A slightly smaller 5-kilometer or 15-mile asteroid makes an appearance every 30 million years. Shrink that down to a 1-kilometer or 3-mile rock, like the recently observed asteroid 2001 FO32, and you're looking at an impact every 700,000 years. As we continue down this scale, the numbers become more frequent. A 50-meter or 150-foot asteroid, similar to the one that flattened Tunguska in 1908, comes around every 2,000 years. The much smaller 20-meter or 65-foot rocks, like the Chelyabinsk asteroid of 2013, make an appearance every 2 centuries. And a modest 5-meter or 16-foot asteroid pays us a visit every 2 years. These figures, while informative, carry a hidden fragility. With the notable exceptions of Tunguska and Chelyabinsk, where we have clear historical records, we simply don't know for sure when the last large asteroid came to call. We have no idea if we are, in fact, well overdue for a significant impact. And here's the most unsettling truth. For many of these larger, more catastrophic events, the sample size used to calculate these averages is, at best, a whopping 1. Think about that for a moment. How much confidence can we truly place in an average derived from a single event spanning the vastness of geological time? It's a humbling thought how much uncertainty lurks beneath the surface of what often feels like settled science. Of course, not all predictions rely on such broad historical averages. When it comes to the probability a specific asteroid will impact Earth, the methodology shifts. These predictions are based upon multiple observations and meticulous orbital calculations over time. The more observations we gather, the more reliable the prediction of that particular asteroid's trajectory and potential threat becomes. For instance, a relatively small 8-meter or 26-foot asteroid named 2017 WT28 currently has a 1% chance of impacting Earth in November of 2104. This isn't just a guess. It's based on a respectable 28 observations and the subsequent orbital calculations gathered over 19 days. That gives us a degree of confidence. However, the universe is vast and our surveillance is far from perfect. Consider the NEO asteroid 2010 WC9. It was discovered in 2010, but then, rather alarmingly, it was lost later that very same day after it grew too faint to track. Then, without warning, this 100-meter or 330-foot asteroid suddenly reappeared in May 2018, winging by at half the distance between us and the Moon. It was a stark reminder of how quickly these celestial visitors can vanish and reappear, seemingly out of nowhere. And 2010 WC9 is not alone. There are nearly 1,000 such near-Earth object asteroids that were briefly observed, perhaps for a few hours or a day, and then simply disappeared from our tracking. But the problem goes even deeper. An astonishing 130,000 asteroids weren't even observed, or their orbits calculated long enough to receive a provisional designation, or for us to determine if they posed any threat to Earth at all. While most of these so-called lost asteroids are likely small and relatively harmless, dozens are estimated to be greater than 400 meters or 1,300 feet in size. That's a significant number of truly unknown objects silently charting their courses through our cosmic neighborhood. As if the challenges of small sample sizes and lost asteroids weren't enough, there's a further, fundamental complication. Probabilities often assume that the orbits of these asteroids will not change. But in the dynamic dance of our solar system, nothing is truly static. Let's consider asteroid 4179 Toutatis. This is a formidable 2.5 kilometer or 1.5 mile monster that made a remarkably close approach to Earth in 2004, coming within just 4 lunar distances. This was the closest approach of any asteroid of this size in this century. But Toutatis is particularly challenging because it possesses an incredibly complex and chaotic orbit, heavily affected by the gravitational pulls of both the Earth and the gas giant Jupiter. Its path is so intricate, so prone to subtle shifts and perturbations, that experts simply cannot accurately predict its long-term danger to Earth beyond a few centuries. Beyond that time frame, its trajectory becomes too uncertain, too sensitive to tiny, unmeasurable variations to offer any reliable forecast. It's a potent reminder that even for objects we know well, certainty can be elusive. So what do we take away from this journey into the world of asteroid prediction? Perhaps it's a realization that while we make incredible strides in understanding our universe, the comfort we sometimes seek in broad averages can be a deceptive one. The reality of asteroid impacts is far more nuanced, a complex tapestry woven with threads of known data, vast unknowns, and the inherent chaos of celestial mechanics. It's a continuous, evolving challenge for scientists, one that demands constant vigilance and ever-improving technology. The next time you hear a statistic about cosmic impacts, consider the story behind the numbers. Consider the missing observations, the chaotic orbits, and the humbling fact that the universe still holds so many secrets. It's a vast, dynamic place, and our understanding, while growing, is always a work in progress. What are your thoughts on these cosmic probabilities and the challenges of prediction? Do you find solace in the averages, or do the unknowns give you pause? Share your insights in the comments below. If you found this discussion thought-provoking, please consider liking this video and subscribing for more explorations into the fascinating and sometimes unpredictable world around us. Thank you for listening.